everyone, this is Professor Sukruti Joshi from LG Institute of Engineering and Technology, Ahmedabad. I am going to take the video lecture series on chemistry. The subject code for chemistry is 311001. In our previous session of this particular subject, we have studied our chapter number 6, which is fuel and combustion. In fuel and combustion, till now we have studied about different classification of fuels, what is the meaning of combustion, what do you actually means or what do you actually understands when we talk about a primary fuel or a natural fuel, right? And even we have seen what is an artificial fuel or what is a secondary fuel. So here we will take a look on the types or analysis of coal. As in our previous sessions, we have studied that which are the analysis of coal or which are the types of analysis of coal is involved. Till now we have studied that coal rank plays a very important role when we deal with any kind of application, right? Because the characteristic of a fuel or a characteristic of a coal is only and only decided by its analysis or by its rank. And to do that coal ranking, we need to do the analysis of that coal. Here, in this particular one, we have deal with two different types of analysis. Number one, which is referred as proximate analysis, while number two, which is referred as ultimate analysis. Okay, proximate analysis, in this particular kind of analysis, the percentage of carbon is indirectly determined. It is a quantitative analysis of the parameters. Which parameters? The parameters like moisture content, volatile matter, ash content, and even fixed carbon. This particular parameters gives us an idea about the percentage of carbon which is present in coal. As we know that wood contains a very low amount of or very low percentage of carbon, while anthracite contains highest percentage of carbon present in it. As the percentage of carbon increases, the calorific value of that coal is also increases. Now we need to understand it here properly, that why it is so much of importance. Okay, let's begin with one by one things. Number one, which is moisture content, right? Moisture content, we can determine it by weighing it before and by weighing it afterwards. How? We have to take 1 gram of our sample or a powder or finely powdered cold sample in a crucible. We have to put it into a hot or electric oven, right? When we put it inside the electric oven for 1 hour, we will wait again. When we wait, we get an exact idea that how much moisture content is evaporated during that particular thing, right? So we can calculate it using the formula, which is percentage of moisture present in it is equal to the loss in weight divided by weight of coal taken into 100. When we put the values, we get an idea about the percentage of moisture which is present inside our coal sample. Maintain it here properly. As the moisture content is low, the percentage of carbon is high, and the percentage of carbon is high, its calorific value will be high. When the calorific value will be high, its rank will be high. Okay. Next is the analysis of volatile matter. Volatile matter is basically a matter which is evaporated when we heat it at a very high temperatures. Okay, so the process involves like this. The dried sample is taken in a crucible and is then covered with a lid and placed in an electric furnace or muffle furnace at approximately 925 plus or minus 22 degrees Celsius. Right? We have to heat it at very high temperatures in order to evaporate the volatile matter from the coal sample. Okay. Now, the crucible is taken out of the oven After 7 minutes of heating, the crucible is cooled first in the air, then cooled down in the desiccators and weighed again. The loss in weight is reported as volatile matter on percentage basis. So you need to make sure that again here, as the amount of volatile matter increases, the percentage of carbon decreases. The percentage of carbon decreases, along with it the calorific value also decreases, and the calorific value decreases, its rank will also decrease. Okay, here we get the formula, which is percentage of volatile matter is equal to loss in weight divided by weight of coal taken into 100. When we put all the values here, we get an idea that how much amount of volatile matter is present in our coal sample, and depending upon that we can get an idea about the percentage of carbon, right? Let's move ahead. We have here the ash content. Okay, the ash is the residual part, we all know that. Fine. So here what we need to make sure that the residual coal sample taken in a crucible and then heated without lead in a muffle furnace at 700 degrees Celsius plus or minus 50 degree or 5 degrees Celsius for half an hour, right? We need to make sure that here that a residual coal sample means after combustion, when the coal is remained, that particular sample is taken and it is heated without any kind of lead. So what is the ash that is left there at this much high temperature? That gives us an idea that how much fixed carbon and how much percentage of carbon is present in our sample. Okay. Now, the crucible is taken out, it is cooled down in air first, afterwards it is cooled down in the desiccator, and then it is weighed, right? When we weighed it, at that time we need to make sure that it is totally cooled down, right? Otherwise the weight will be wrong. Herein, cooling and weighing are repeated till a constant weight is obtained. The residual is reported as ash on percentage basis. Okay, you need to make sure that it will be obtained on the percentage basis. A percentage of ash can be calculated using this formula. Again, the percentage of ash is equal to weight of ash left divided by weight of coal taken into 100. Make sure that you have to take the weight of ash left after the combustion, after the reheating, everything after the heating of the residual coal, etc. will be done. Afterwards, we have to take it into consideration. Okay. Now, last but not the least is fixed carbon. What is the meaning of this fixed carbon? Right? It gives us an idea about the percentage of fixed carbon which is present inside our coal sample. Okay, the coal sample should contain a very high amount of it. In order to do it, we get the formula, which is percentage of fixed carbon is equal to 100 minus percentage of moisture plus volatile matter plus ash. So in short, I should say that whatever the amount left after volatile matter, after moisture contained and ash is minus or else basically substituted, it will give rise to the amount of carbon which is already present in our sample. And it gives us an actual percentage of carbon, an actual calorific value of a coal sample, and it gives us the actual rank of that coal, right? So it is very important for us to get the value of fixed carbon. Now, let's move ahead to the significance of proximate analysis. Significance means what is the importance of proximate analysis. So proximate analysis provides following valuable informations in accessing the quality of coal. Right? It gives us idea about this particular things. First one, moisture. So moisture is a coal evaporates during the burning of coal and it takes some of the liberated heat in the form of latent heat of evaporation. Okay. Therefore, moisture lowers the effective calorific value of the coal. Moreover, over it quenches the fire in the furnace and hence lesser the moisture contained, better the quality of the coal as the fuel. So as I said, less the moisture contained, more the percentage of carbon. More the percentage of carbon, the more calorific value. The more calorific value, the higher the coal rank. The higher the coal rank, the better the quality of the coal is. Okay, in this manner, we can analyze or we can understood the significance of the moisture content or significance of our proximate analysis, right? Second one is the volatile matter. So what is the significance of determining the amount of volatile matter which is present in the coal sample? So here a high volatile matter content means that a higher proportion of fuel will distill over a gas or a vapor, a large proportion of which escapes unburnt. So higher volatile content in coal is undesirable, right? A high volatile matter containing coal burns with a long flame, with high smoke and has low calorific value, and hence the lesser the volatile matter, the better the rank of the coal. Okay, the lesser the volatile matter, the higher the percentage of carbon and the higher the rank of the coal. In order to get this, we have to understand the process and the importance of the volatile matter. Next is ash, right? So ash is basically a useless non-combustible matter which reduces the calorific value of a coal. Moreover, ash causes the hindrance to the flow of air and heat and thereby the lowering the temperature. Okay, the presence of ash also increases transporting, handling and storage costs because it is of no use. When we have anything which is of no use, then it will increase or it is not cost effective, right? It also involves additional cost of ash disposal because we cannot dispose ash in air as such. So we should have a proper protocol for its disposal also. Okay. Next is fixed carbon. Fixed carbon again plays a very important role. Higher the percentage of fixed carbon, greater its calorific and better its quality, right? Greater the percentage of fixed carbon, smaller is the percentage of volatile matter. Hence, higher the percentage of fixed carbon is very, very desirable in order to get a very good calorific value. And if the calorific value is high, then the amount or basically I should say the rank, the coal rank is high. So that coal is considered as a good coal. Okay. This is all for this session. Next we will see in our next session. Thank you so much everyone.